Greetings everyone. In this video we'll be looking at NCEA level 3 probability distributions achievement standard, and in this video I'll be going over distribution table and finding the expected value or mean, variance and standard deviation. The average or mean of a random variable is expected value, and it is the value that we get after long run experiment, and it is also known as weighted average. And the symbol that's used is E of x, is same as mu, which is the mean symbol. Note that these symbols are used interchangeably and they mean the same thing. The concept of expected value is extremely useful in decision making, and for discrete variables the mean or expected value is given by a sum of x times the probability of x. And the variance and standard deviation is the measure of spread, and variance is given by sigma squared, which is same as E of x squared minus mean squared. So if you're finding the standard deviation, just need to take square root of variance x. You'll be able to find the value of the standard deviation. Note that these symbols are also used interchangeably. You do not need to memorize these formulas. These will be made available to you on the resource sheet. So we'll look at the exam type question, and in this example it says while investing on a particular stock market, an investor knows that in a given year he can take a profit of $5,000 with a probability of 0.3, or take a loss of $1,000. And then the first part to the problem says what is the investor's expected gain or loss on the stock. And the second part of the problem says what are the variance and standard deviation of the investor's gain on the stock. So we'll begin by setting up the distribution table. We know that the random variable x is the profit that he can take. So if it's a profit, then it's a positive $5,000. Loss, of course, will be negative 1,000. The probability is 0.3 for a profit of 5,000, and 0.7, of course, it will add up to 1. Also 0.3 plus 0.7 is 1, so negative 1,000 will have a probability of 0.7. And then using this we can find the expected gain. So E of x is equal to mean, which is mu, and E of x is given by sum of x times the corresponding probability, so 5,000 times 0.3 plus negative 1,000 times 0.7. And if I've got few other items here, we will continue with that process. So we've got 5,000 times 0.3 plus negative 1,000 times 0.7, which gives a value of 800. And then this means that the investor's expected gain is $800. Now in this case, it's a gain because it's a positive value. If you ended up with the answer that gives you a negative result, that means you got expected loss, and it's not good to proceed with that sort of investment, which helps you with decision making. Moving on, part 2, it says find the variance. So variance is given by E of x squared minus mean squared. So we're given the x value in the table, but the formula says find the expected value of the x squared. So what we need to do is square each of the x values, and then do the same thing that we did for expected value E of x, multiply by the corresponding probability. So we'll quickly do that. So we know that mean is 800 from the previous part, and E of x is given by 5,000 squared. It's now x is squared, so 5,000 squared times the corresponding probability 0.3 plus negative 1,000 squared times the corresponding probability 0.7, which gives you 8.2 million. And then variance is given by E of x squared minus mean squared. Now E of x squared value is 8.2 million, so we'll put that together. So 8.2 million minus mean squared. Mean was 800, so it's 800 squared, and that simplifies to 7.56 million. So that's the variance value, and we know that the relationship between variance and SD is square root. So if I take square root of variance, I will be able to get the standard deviation value. So taking square root of 7.56 million, we end up with $2,749.55, and that's the standard deviation value. Once you've got this, then you will need to write the answer in context. The investor's expected gain is $800 with a standard deviation of $2,749.55. Thanks for watching. I'll see you guys in the next video.